Hi guys, and welcome to the video on functions. We're going to start this video off with a definition. A relation is a set of ordered pairs. The set of the first components of each ordered pair is called the domain, and the set of the second components of each ordered pair is called the range. So if we look just below, we actually have an example of a relation. This 1, 2 represents one ordered pair. Similarly, this 2, 4 represents another ordered pair, and the set of these ordered pairs together is called a relation. So if we just look at the first entry of each ordered pair, so 1, 2, 3, 4, 5, we can classify these numbers as the domain of the relation. And if we look at the second entry of each ordered pair, so 2, 4, 6, 8, 10, we can call these numbers the range of the relation. We can refer to a single element of the domain as an input value or independent variable. So, for instance, 1 is an input value, and so is 2. Each value in the range can also be thought as or called an output value or a dependent variable. So 2 is an output value, and so is 4, so is 6, so is 8, so is 10. So usually we like to label the input values with a lowercase x, and the output or dependent variable we usually label with a lowercase y. So we're now going to move on to another definition, a very important definition in mathematics, a function. So a function is a relation in which each possible input leads to exactly one output. Okay, so we're just going to look at some examples up here, this A, B, and C. So let's look at A. So we have our inputs P, Q, and R. Is this a function? So we need to ask ourselves, does each possible input lead to exactly one output? So we have P. Does it have one output? Yes, M. Q. Does it have one output? N. Yes. R. Does it have one output? N. Yes. So this relation right here that's described in A is indeed a function. Similarly, in B, each input, P, Q, and R, is associated to exactly one output, which is clear from the diagram. However, in C here, we do not have a function. So let's just see why. So the input P, yes, that is associated to just one output. However, Q is associated to two outputs, and that violates the definition of a function. So just remember, for a function, we need one input to correspond to exactly one output. This Q corresponds to two outputs, thus violating the definition of a function. So now we are going to look at examples of functions as well as finding input and output values of a function. So let us look at this function here. F of x equals x squared plus 3x minus 4. We would like to input these things, so choices A, B, C, and D, into this function and see what the output would be. So let us look at this. So for A, the input value is a number 2. So this just means wherever we see x in the function, we are going to replace the x with a 2. So this would give us 2 squared plus 3 times 2 minus 4. And we can simplify this to 4 plus 6 minus 4, and this equals 6. For part B, it is telling us to input a into our function. So just as before, all this means is that wherever we see an x in our function, we replace it with an a. So all this will look like is a squared plus 3a minus 4. For C, it is slightly different. We have an input value of a plus h. So just like in the other examples, wherever we see an x, we are going to replace that with a plus h. So right here we have f of a plus h. This will equal a plus h squared plus 3 multiplied by a plus h minus 4. So all we did is we had an x squared. So instead of x squared, we are going to put a plus h squared. We had a plus 3x, so we're going to replace the x with a plus h, so plus 3 times a plus h, and then minus 4. And then if we would like, we can simplify this. We can multiply the a plus h by itself. We can square it, and that will give us a squared plus 2ah plus h squared. We can distribute the 3 into this parenthesis, and we get 3a plus 3h, and then the minus 4. So another example is this function g of m, which is the square root of m minus 4. And they're asking us to evaluate g of 5. So what that means is that wherever we see an m in our function, we're going to replace that with a 5. So if we do that, we would have the square root of 5 minus 4. Well, 5 minus 4 is 1, and we're taking the square root of that. So g of 5 is equal to the square root of 1, and the square root of 1 is 1. Given a graph, an easy way to determine if the graph represents a function is to use the vertical line test. So let us describe what this is. Given a graph, use the vertical line test to determine if the graph represents a function. So 1, we inspect the graph to see if any vertical line drawn would intersect the curve more than once. If there is any such line, we can determine that the graph does not represent a function. So let's look at these figures here. In this graph, any vertical line that is drawn through this graph will just intersect the graph in one spot. However, in these two examples, if you draw a horizontal line here, it crosses the graph in 2 spots. And similarly in this one, a horizontal line drawn, a vertical line drawn here will cross the graph in 2 spots. So these two do not represent functions. So let's look at another definition here. A one-to-one function is a function in which each output value corresponds to exactly one input value. We have an easy test to see whether a function is one-to-one. This is called the horizontal line test. So once we have determined that a graph defines a function, an easy way to determine if it is a one-to-one function is to use the horizontal line test. You draw horizontal lines through the graph. If any horizontal line intersects the graph more than once, then the graph does not represent a one-to-one function. So if we go to this graph here in A, if we draw horizontal lines through this graph, well, we see that if we draw a horizontal line through here, it's going to hit the graph here, here, and here. So A here does not represent a one-to-one function. In B, drawing horizontal lines through this graph, each horizontal line crosses the graph just once. So B is a one-to-one function. And in C, if we draw a horizontal line through the circle, the graph will cross this horizontal line in more than one spot. So C is not a one-to-one function. So now we're going to be looking at some examples of functions and how to graph them. So the first function we will look at is f of x equals x. So what I like to do now is to set up a table with 2 columns. The first column will be x, and the second column will be f of x. Okay? And we're just going to now list some x values. And we would like to look at their corresponding output values. So if we plug -2 into this function, we will get back -2. If we plug in -1, we'll get -1, 0, 0, and 1, 1. So now we can draw our coordinate axes and try and find a graph for this function. So I'm just going to label our x 2, -1, 2, 1, 2, -1, -2. Okay, so if we go to our x value, -2, we see that the function evaluates to -2. So here's our x-axis, and here is our f of x axis. So if we go to -2, we go down to -2 here, and we'll put a point there. For -1, we'll go down to -1. For 0, we'll go to 0. For 1, we'll go to 1. And for 2, we will go to 2. And now all that's left to do is to connect the dots. So I will try and do this as neatly as possible. And that will be the graph of our functions. It's supposed to be a straight line. The next function we'll look at is f of x equals the absolute value of x. So what the absolute value function does, if you put in a negative number into it, you will just get back that number, but without the negative sign. So if we plug -3 into the absolute value, you just get 3. If you plug in a positive number, such as 2, you will just get the number back. If you plug in a negative number, like -5, you would just get 5 without the negative sign. Okay? So let's try and find the graph for this function. So as before, I will make a table with 2 columns, f, x, and f of x. -2, -1, 0, 1, and 2. And now we need to look at the corresponding outputs for these x values. So -2, the absolute value of -2 is 2. Absolute value of -1 is 1. 0 goes to 0. 1 goes to 1. And 2 will go to 2. Okay? So now let's draw our coordinate axes and try and get a graph here. So I'm going to denote my x-axis here with -2, -1, 1, and then 2. And my f of x-axis or y-axis will be 1, 2, and -1, -2. Okay, so let's go to -2. At -2, the function will evaluate to 2. At -1, it evaluates to 1. At 0, it evaluates to 0. At 1, it evaluates to 1. And at 2, it evaluates to 2. So now we'll just connect the dots. And that will be the graph of f of x equals absolute value of x. And the last function we'll consider in this video is f of x equals x squared. So what this function does, it takes an input x and it returns its square as an output. Okay, so let's get some x values going. Okay, so if we plug -2 into f of x equals x squared, we're going to do -2 squared, which would be 4. -1 squared is 1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. So now we're going to go over to our coordinate axes here and try and find a graph. So at -2, this function evaluates to 4. So I'll put a dot up here at 4. At -1, it evaluates to 1. At 0, it evaluates at 0. At 1, it evaluates at 1. And at 2, it evaluates to 4. Okay? So this is what the graph will look like.